before we'll jump into consistency and different types of it, let's look at the previous session, what we have learned. It's a quick recap that we'll do it. So here we talked about availability and as well as fault tolerance and resilience, and how we can make a system fault tolerant by providing more than one web servers or database in database layer or web tier under auto scaling group, and how they will help that even one fault that maybe one web server is down or one database is down, still system will be providing the required services. So there will be no downtime, or the service is not completely available. The service is still available even though the fault is there. And next we have seen the resilience is the ability of system either to withstand and recover from failure. So even if any system, maybe all web server go down, all databases goes down, but what is the ability of system to come back to the normal operational conditions? So that is what the resilience is. So this is what we have learned in our previous session. We also looked at scalability, what exactly is scalability, and we have seen the horizontal scaling and vertical scaling. So in this, we have seen that, okay, adding more machines is one option where we can add more machine as per the user requirement. Like as the traffic is increasing, we'll keep on adding more machines, and these machines will be part of an auto scaling group where maybe the minimum will be 2 or maximum will be 8. So according to the traffic, the number of machines will automatically get added to the sources as a resources, or it will automatically get removed from the resources. And for vertical scaling, it's just one machine where we are increasing the capacity like CPU, RAM, or storage. So that is what. And we also seen a hybrid approach where we have a high scale machine where its configuration is higher, and same machines we are multiplying just like horizontal scaling to serve both the things. Like it will have benefits of both with stronger machines and with horizontal scaling. Okay, so that is also we have seen. And what we are going to look at it today is called consistency. So let's start with it. So let's, as we always do, let's look at a book definition and then I'll explain it in my own language. But consistency refers to the property of ensuring that all nodes in a distributed system have same view of data at given point of time, despite of any concurrent operations or network delays. I'll just try to elaborate this. That suppose you are writing an information to database and immediately you're reading that information. So maybe it's you or maybe there are other users, those who are doing this writing operation and reading back it. So they should get the exact same data that has been written to the database. So that is what it is expected that any user, suppose user one is writing some data and user maybe at 900 or 1000 place who's trying to access the same data at the same time, that user should get the data that is written by user one. So this is what we are saying, like concurrent operations, like some users are at the same time, they're writing this operation, like they're writing the information to the database, and the other user, which is maybe far away, maybe there are multiple users, those who are trying to read that data, they should get the same data that is written. So again, we will get into more details. So there are pros and cons both, but we'll look at it. And here it is mentioned in simple term, it means when multiple client access or modifies the same data concurrently, they all see the consistent state of data. This is what I mentioned just now, that multiple clients or multiple users trying to access, either they want to read it or either they want to modify the data at the same time, they all should see the consistent state of data. Okay, we'll get into more details of it so that as we look at the types, then you'll realize that what is exactly it is. See, consistency is just imagine that you're writing something and maybe other users are reading it. So whenever you're writing and at the same time someone trying to read it, they should get the last written data itself. Okay, and that is important depend on system to system. So let's look at the type, then we'll have a clear information about it. The first type is strong consistency. What is the meaning of strong? That we'll understand here. It guarantees that every read operation return the most recent write. That means what I've written, that will be immediately responded back. Okay. And ensures a uniform and up-to-date view of data. So data will have high level of accuracy or correctness. Okay. So that means whenever you write any data, that the same data will be available. Now you will see how it is possible. So there will be kind of trade-off. See, consistency, maintaining a consistency is not easy, but you have to sometime sacrifice latency and availability. In the sense, you will not get fast response. Maybe your system will be not available for certain time. So you have to do some kind of trade-off between consistency and latency and availability. So these will be kind of trade-off you have to do when you, maybe you can delay some response for some time, but you will get the exact data after that. So why that delay and why this is happening? Let's look at this. See, example I have given is financial transaction. For just take an example that if you go to an ATM and you remove some cash, okay, and suppose after some time, maybe you went to another ATM, or after some time, after removing cash from one ATM and you went to another ATM, maybe from another bank, and try to remove another cash, you will get to know that the cash that has been removed from first ATM and whatever the balance is, you will get the same balance in the other ATM. So what is happening behind that? Your data is immediately returned to the database. And if the data is not written, sometime you go to the same bank and you see that the system is not available or the ATM is not available to remove the cash because there is some inconsistency. See, I'm just giving one of the example. There may be network issue, there may be electricity issue, it may be anything, but there are sometimes inconsistency in data itself. Then that system is not available. Maybe sometime you go to any ATM, maybe that this is one of the issue because of which ATM may not be available for you. So it's crucial in case of financial transaction. Just imagine if you are removing your cash and your amount is not deducted from your account and you have your cash in hand. So this will be inconsistent data. So for financial institution or financial organization, definitely they will have some kind of inconsistent uh, data available with them. So they have to keep track of it, remove that inconsistency, and then only start responding to people. So in that case, the strong consistency is important because financial data is very critical for any financial organization. So what we do usually, see the strong consistency, how it works. I've just given an example here that suppose user working with an ATM, like he's trying to remove the cash. So that removal cache process will first from web server, whichever web server handling that transaction, will first go to primary database. What primary database will do, because primary database is not the only database. We also have multiple database. We create a lot of replicas behind in backend. So what web server will do, web server will send that write request to primary database. The primary database, after written to itself, it will send that information to multiple replicas. So all the replicas will be updated with the same information. And in this case, see, the request has gone to primary database. Primary database send those requests to replicas. A replica will copy that information in their own databases, and then they will send a kind of acknowledgement to primary database and saying that, you know what, we are done with our operations. So they will send kind of acknowledgement, and then web server will get an acknowledgement that yes, the write operation is done, and then web server will send that notification back to user. So this is the entire process has been followed, and until and unless this whole process is not done, you will not receive any notification. So this is needed if you need strong consistency. If any of the operation is failed, the system will not available or that will be high latency. You will not get response quickly. So that is what the strong consistency. Strong consistency means the data should be consistent every time you try to access, or when you modify it, that updated information should be quickly available to any of the user who's using your system. Okay, so that is the main idea behind it. So it is called strong consistency, and mainly in financial organization or financial transaction, we use strong consistency. I hope it is clear. I'm just moving into eventual consistency so that we'll understand the difference as well.
Shashant, I have one question. Uh,
Yes.
how this strong consistency is different from the slave data? Because we are doing the same kind of thing in the slave data as well. We are writing the data and reading the data in the same time through the server.
Yeah, that's for sure. See, when we are writing data to slave, okay, but when we are writing this operation and at the same time, suppose someone else is trying to access the same information which you have written to slave data. Okay, because see, first data has been written to primary database or master database, then
Yes.
it goes to replicated to slave databases. Okay, what if the slave database, one of the slave database where we are writing the information and from where user is trying to read it, that database is down due to some reason. The information that is written to it, it is not available then. Okay, if the database, the slave database is down or it's not available due to some reason, then we have to do behind the scene, we have to do, okay, we have to restore that database to read it. We have to see that all the data is replicated properly to it. So till that time the data is not available for the user, because user is trying to read that. Either user will be diverted to another slave database or user will be waiting for that information. So in that case, definitely there will be strong consistency will be there. I mean, the user will get access to that information, but for user, it will be a delay in the response, or either it will be the service will not be available. User will get some message for user that the service is not available at this point of time.
So
Both
it has a
possibilities are there.
single point of failure on that time.
No, not single point of failure. It's not a single point of failure. System will be restored. But
Mhm.
it all depends on systems. If you have one slave database, definitely it will be a single point of failure. But if you will be have multiple database slave databases, then it will be delay in the response. What we have
Then it
seen
will not
in
support that strong consistency, right?
exactly. Strong consistency is not response. Strong consistency is getting the right information, the latest information. Strong consistency is not related to response. Strong consistency is related to data. What kind of data you are getting? Because we are not responding to user. User should get the latest information. That is the important of consistency is the data that we are extracting from the system or getting as a response. That data should be the latest data that we are looking for. The latest data that is written by maybe any other user. So just imagine when your friend is writing a post on Facebook and he has put that post, he has published that post, and immediately it's available for you. Okay, so that will be still there'll be kind of delay, but that will be, I'm just giving an example, that will be a kind of strong consistency. Practical it is not, but I'm just giving an example that it is strong consistency because it is immediately available for you. But if something happened, like slave database is gone when you're reading from it, you will get the response, you will get his post from the, but if that something happened to that database, you will not get immediate response. There will be latency, high latency. There will be delay in getting a response, but you will get the right information. You will get the latest information. So, just trying to say that consistency is nothing to do with the response that you get or the system availability, because this is the trade-off when we design system, that we have to choose whether we want a strong consistency or whether we want to have low latency or high availability. That is a choice that we have to make when we design this kind of system. So if you want strong consistency, yes, but then you have to See to it that your system may not be available, your system will have high latency, so that you have to do choices. Like financial system, they have this choice that they will give you the right data, but their system will not available, or their system will give you a kind of response. Like few days back, I was checking my mobile app and I was going through my banking app, and I saw this that app was not available. I was continuously trying for almost an hour, but the app was not working. So I was thinking that there may be kind of data inconsistency, or maybe network issue, or maybe some other issue. That's why system was not. But data consistency is a critical one for financial uh, transactions or financial related uh, any process. But it is more important that consistency is nothing to do with responses that you're getting. It's more of data that you get. You want to have the latest data from your system.
Okay.
I hope now
Yeah.
it is clear.
Yes. It relates
Okay.
to the accuracy of the data, not for the like
Yes.
time of that data
Yes.
we are getting.
Right.
Yeah.
All right. Moving on to eventual consistency is, see, it allows some delay. So here what we are doing, we are uh, giving more important to we are giving more important to having to latency than the data itself. See, let's understand it. Allows some delay, but guarantees that if no new updates are made, all replica will converge to the same value eventually. In this sense, in eventual consistency, let's look at this example. See, web server is sending the data to primary database. But what primary database will do, it will not first write to a replica. It will immediately send response to web server, giving an acknowledgement that yes, your data is received and it is written. And then eventually, over the period of time, primary database will replicate that data to multiple replicas. Okay, here I have just shown one, but replicas may be multiple slave databases. So these are the things that here what primary database is doing is quickly sending the response back to server that, you know what, I have received the data I have written, but the data is not written to multiple replicas. It will later on, or eventually it will write the data. So in this case, what will happen? Your replica will not have latest data. And at the same time, when the user is sending the request, maybe some other user trying to read the data, but that data is not available in the slave database or in your replicas. So you try to read the latest information, you will not get immediately. But as primary database is behind the scene writing that information or copying that information to the replicas, then after some time the replica will have a latest data. That's why it is called eventually. It's an eventual consistency. This is over the period of time. Maybe it may not take much time. Here I have given an example of YouTube video count. So view count is there. If you have seen, you're watching a video, and in some time I have seen that number changing in some time. I don't remember whether it is 5 second or 3 second or 10 second, but the numbers is keep on changing view count. So because this number is not important for the user. It's just changing. Okay, how many view counts are done? Maybe in 10 minutes, maybe 5 minutes. So that is something happening behind the scene that, okay, people are looking at those views, like looking at those videos. So view count is increasing. It is written to primary database. Primary database may be sending response that yes, I got this information, and slowly it is pushing that to replicas. And whenever all the replicas are updated, and whenever the count is reading that information from the replicas, then it's get updated. And it is not that important for users. See, here again, as I mentioned, there is a trade-off between multiple components. So here it is not important. View count is not that important for user, those who are watching the videos. Maybe it is important for the person who's created those videos. But this is again a kind of, it is not important. So delaying that information, it's okay. If user don't get the latest information, it's fine. And let's look at the last type. See, there are more types of it. It's not just these three types are there. There are, I think, 7, 8 types of consistency. But I thought of discussing these because these are the most time you if you see anyone discussing about, they will talk about strong and eventual consistency only. No one will talk about other consistencies. But here we are just looking at it so that at least our idea is clear that what exactly it is and how we can uh, understand it better. And maybe while we'll design a system, we should just keep in mind that what kind of consistency that we require. Okay. The last type is weak consistency. Here, when a write operation is executed against a server, the subsequent read operation against other servers may or may not return the latest written data. See, it sounds like same like eventual consistency, but here the delay will be more because and there will be loss of data as well. See, in eventual consistency, definitely there will be not loss of data because we are writing information to multiple replicas, and that will be when one replica go down, other will take care. But in this case, for example, I just put it that sometime when to give a faster response, to give very high latency. See, eventual consistency will have latency because we are giving data which is available to the primary database. But see, why we are reading directly from database itself. So even database will have some delay. I'm not saying too much of delay, but some delay. But here what we are doing, we want trying to get the faster response. This concept we have seen earlier that we put cache in between web server and database. So here we put cache and cache will give an immediate response. Okay. So what we are doing here is when we are writing information from web server to database, first we'll send that information to cache so that cache can respond to those requests quickly. But what cache is doing, cache will first write that information to a message queue. What is message queue is just a kind of queue where data is stored one after another. We'll get into details of it later. But first it will write information to message queue. And message queue will later, as the queues or maybe whatever information that is stored in queue, it will process by database asynchronously. So it will read one after another. It will take some time. That information should get updated to database, maybe primary database or maybe multiple databases or replicas. So that will be happening asynchronously. Till that time, cache will not wait. Okay. The cache will just send the response back to web server. Once it is written to message queue, cache will send it back to web server. The information is written. But this process that from message queue to replicas or multiple database is happening behind the scene. And it may possible suppose cache gone down or message queue gone down. So if it is not available and then it will restore, maybe some data may loss. But again, it depends on system to system how you design that, how you can see to it that your data should not get lost. You should have that system, maybe not one message queue, maybe multiple message queue. Maybe not one cache, maybe multiple cache. But that is other thing. But for here, what we are looking at is if cache is responding and cache goes down, the data may loss. And to when we restore it back again, we'll get delay because message queue is keep on it's kind of publishing information to multiple databases because databases are subscriber to our message queue and they are just receiving the information. Okay, but it takes much time than the eventual consistency. It will be kind of maybe kind of single point of failure also here, and user will not get the latest information as well as sometime no information. In the sense if some data is lost, that data we cannot recover. See, this weak consistency come into picture only when you want a very low latency, a very quicker response. See, as the consistency goes on increasing from strong to eventual to weak, your latency will increase, but the latest or consistent data is not available for user. And as we go down, your data loss will increase. That is the whole idea behind it. So here we are just talking about data consistency, where data is more important. And as we have seen, the strong consistency where data is, we are trying to give user the as latest information as. If the latest information is important for user, then the latency will be higher or maybe sometime the system will not available. But eventual consistency, we are trying to give the data whichever is available. The data whichever is there written to the replicas, it will be given to user, but that may not be a latest data. And over the period of time, maybe in some time, maybe in seconds or maybe in minute, that data will be available to user. And in weak consistency, maybe data is not even available for user get the latest information. So that data is already lost. So these are chances, and here I mentioned that real-time multiplayer video games or maybe online conference we do. Sometime we are not able to send the maybe the whole audio. It's not reaching to people. So in that case, maybe there is some loss of data, loss of audio data. This is something is important topic, and I would like you to understand the meaning behind these words. And there are more consistency if you read, if you try to go online and try to understand this, you will get more types also. So these are somewhere related to these topics or these types. Is it clear? Consistency? Okay. So let's move to. Do you think that we should move to other topic? Because I think the time is already 30 minutes. Otherwise, we'll stop here and maybe we'll look at the other topics later on because I don't want to go about 30 minutes. So I'll stop recording here.